I'm assuming you've read the question, so let's go ahead and assume that and get started on answering the question. So it says that we want how many acres of each should be planted to maximize profits. So we want to maximize profits, and we want to determine the number of acres of each type to be planted to maximize profit. So we need to make number of wheat acres one variable and number of rye acres the other variable, because that is what's driving profits. And we know that it's 500 per acre of wheat and 300 per acre of rye. That's what we're trying to maximize. 500 of wheat, 300 for rye. Okay, and we have a whole bunch of constraints here. He has 10 acres to plant. So wheat plus rye has to be less than 10. He has to plant at least 7. X plus y has to be at least 7, can include 7, so it's greater than or equal to. He has only $1,200 to spend, so he has to spend less than $1,200. And each acre of wheat costs 200 to plant, and rye is 100. That's a 100. It kind of looks like a 4, but it's a 1. Okay, 200 and 100. He has to get the planting done in 12 hours. It takes an hour to plant the wheat and 2 hours to plant the rye. 1 hour to plant the wheat, 2 hours to plant the rye, and that's a maximum of 12 hours. Wow, that's a lot of constraints. And of course, we can't plant a negative number of acres. Okay? All right, so we need to come up with our intercepts if we want to graph our feasible region. So here our x-intercept is 10, our y-intercept is 10. These are 7 and 7. This x-intercept is 12 divided by 2, so it's 6. The y-intercept is 12 divided by 1. Right? This x-intercept is 12 divided by 1, and the y-intercept is 12 divided by 2. And then, of course, these. So let's get graphing. I'm going to go ahead and graph these and come back. Okay, so I've gone and I've graphed these, and just want to point a couple things out. The x plus y equals 10, it actually doesn't affect the feasible region at all, because we're below this line and below that line, and above the x plus y equals 7. So our feasible region is this small triangle here. So we need to know these points. Our maximized profits are going to occur at one of these points. So this point here, I can tell from my graph, I did a nice job with this. I have 5, 2 is right there. So we're going to test 5, 2. This point here is 2, 5. And this point here is 4, 4. Now, if you couldn't read your graph because you weren't super precise, you are going to have to go through and solve the system of equations. This point right here is x plus y, where it intersects x plus 2y equals 12, right? You'd have to solve x plus y equals 7, x plus 2y equals 12. That would give you that point. This point here is going to be the solution between these two equations, x plus 2y equals 12, and I'm going to divide all of these by 100 to make it easier. That would become 2x plus y equals 12. You have to solve for that point where those two lines intersect. And then to solve for this point, we would have this equation, which I've already simplified here, which is, I'm going to write it up here, 2x plus 1y equals 12, and it intersects with x plus y equals 7. So you'd have to solve these three systems to come up with these points that I was able to read off the graph. Okay. Not sure on the test if you're going to be able to read it off the graph or you're going to have to solve these systems. I can't remember. Okay, so now we're going to plug these points in, those combinations, into our objective equation that we're trying to maximize. So we have 500x plus 300y. Which combination maximizes our profits? 5 times 5 is 2,500. 2 times 300 is 600. So that's 3,100. This is going to be 1,000, and 5 times 3, 1,500. So it's definitely not that one. Okay. 4 and 4. Let's see, 2,000 and 1,200, 3,200. There's our maximum profit. Okay, just by $100. So the answer is going to be planting 4 acres of each rye and wheat will result in a max profit of $3,200. Okay, done.